Hey everybody, we are ready to start section 5.2, and this is on factoring trinomials. Now we're going to start with trinomials that are actually fairly easy to factor, and those are trinomials. So tri means three, right? So three terms, we have three terms here, and a lot of those can be factored. And the ones that are the easiest are when the coefficient of this squared term is 1. So notice we have a coefficient of 1 for all of these. There's no other number in front. So those tend to be the easiest, and to factor them, what we do, the technique we can use is to take the 3, the last term, which is 3, and we try to find two factors of 3 that will add up to the coefficient of the middle term. In this case, just the single variable term. So the coefficient is 1, right? So are there two factors of 3 that will add up to 1? So the factors of 3 are really 1 and 3, or negative 1 and negative 3. And there's actually no way to get 1 from those factors. And so this first one is actually unfactorable. The only factors of 3 would be 1 and 3. If we add those together, we get 4. Or we could use negative 1 and negative 3. If we add those together, we get negative 4. Neither of those result in 1, which means this is an unfactorable trinomial. When a trinomial is not factorable, we say it's prime. Okay? So this one is prime. Now most of these you are given will be factorable, but I wanted to start with an example that was not, as kind of a special case where you just can't find anything that will work. So let's look at one that's a little more interesting, one that will work. So the next one, we have a trinomial. Leading coefficient is 1. We're going to take the constant term, this guy here, the term without a variable. We're going to find two factors of that guy that will add up to the coefficient of the middle term. Okay? So two factors of 28 that add up to 11. So if we think about the factors of 28, what goes in 28? Well, 1 and 28, that's not going to work. 2 and 14, that's not going to work. 3 doesn't go in 28. 4 and 7, well, 4 plus 7 is 11, but this is a negative 11. So we could use negative 4 and negative 7, right? Negative 4 times negative 7 is the 28. And if we add them together, we get negative 11. All right. So what do we do with these? Well, so this negative 4 and negative 7 are going to become the constant terms of our two binomials. So we're factoring the trinomial into two binomials, which means two terms, right? So in order to get an x squared, we need an x times x, right? So we're going to have an x and an x. And in order to get the 28, we're going to use our minus 4 and our minus 7. So we have x minus 4 and x minus 7. And that's your answer right here, x minus 4 times x minus 7. Now it's not a bad idea to check to make sure this actually works, right? So in order to check, we would multiply these together. Multiplication is really the opposite of factoring, right? So we could go backwards. If we multiply these two binomials, we could use what we call the FOIL method. A lot of you like the FOIL method, right? First times first, x times x is x squared. First outer, inner, last, right? Outer times outer, negative 4. So x times negative 7 is negative 7x. Inner times inner, negative 4 times x is negative 4x. But if we put those together, negative 7x, negative 4x, that gives us our negative 11x, right? And then last times last, negative 4 times negative 7, that gives us our positive 28 that we needed on the end. So we have successfully factored this trinomial into two binomials. All right, let's look at the next one. X squared minus 8x minus 33. All right, so we use our old technique. If we take the constant term on the end, this is a negative 33, We want to find two factors of negative 33 that will add up to negative 8. So 33 doesn't have a whole lot of factors, but let's see, 3 and 11, right? 3 times 11 is 33. So we can probably use 3 and 11 somehow, but one of them has to be negative, right? So we have to decide which one is going to be negative. Well, in order to get a negative 8 in the middle, the larger one has to be negative, right? So we need a negative 11 and a positive 3, right? Negative 11 plus 3 is negative 8. Negative 11 times 3 is our negative 33. So we have our two binomials. X times x, again, is our x squared. So we have our x and our x. And then we use these two guys that we found here that add up to negative 8 for our constant terms in our binomials. So we have x minus 11, x plus 3. And again, you could use the FOIL method. That's something we assume you know coming into this class, but if you forget, you take the first times the first, x squared, outer times outer, 3x, inner times inner, negative 11x. So that's where the negative 8 comes from, right? Negative 11x plus 3x. And then we have last times last, negative 11 times 3 is negative 33. And we've successfully factored that trinomial. Now the ones at the bottom are a little bit more tricky, but not too bad. These are examples. A lot of times you can factor out a greatest common factor first and then factor the trinomial. The examples we had up here, there's nothing you can factor out of the three terms, right? Nothing, no common factors in the three terms. But if we look down here, for example, example 4, we can factor out a GCF first and then work on the trinomial. So if we look at these three terms, they all have, well, 2 will go into all of them, right? So let's factor out a 2. N squared will go into all of them, so let's factor out an n squared. So let's see what we get after we do that. Factor out a 2n squared, we would end up with an n squared here, and an 8n here. And let's see, 2 goes into 30, what, 15 times? And we have the n squared already, right? Alright, so you might think, well, I'm done, I factored out the GCF, but you're not done. We did factor out the GCF, but now we have a trinomial that could possibly be factored as well. So I'm going to take this 15 and do what we did before. Are there two factors of 15 that will add up to negative 8? So if they're good, it's a negative 8, they're both going to have to be negative, right? And let's see, to get 15, 3 and 5, right? Negative 3 plus a negative 5 will give us our negative 8 that we need, right? So the 2n squared doesn't go away, it's still hanging out here. But this trinomial we can factor into two binomials. And to get the n squared, we have an n times an n. And to get the 15, we have our negative 3 times negative 5, so we're going to have a minus 3, minus 5. Now again, you can check this. You could use the FOIL method to multiply the two binomials. That should get you back to this trinomial. Once you get your trinomial, you can multiply by the 2n squared to get back to where you started. You can always work in reverse using multiplication to make sure you did everything correctly. But anyway, this is our answer. It's now completely factored. Good news, right? That would be your answer. So number 5, let's see. We have a trinomial. Can we factor something out of all three of them? This one's a little more tricky because we do have two variables involved, right? So that gets a little tricky, but let's see what we can do. We can factor a 2 out of each of these again, it looks like. We can factor out an A, it looks like, and a B, it looks like. And so let's see what we're left with. We factor out a 2ab. The only thing we're left with here is an a squared, right? 2 times 5 is 10, so we have the minus sign, we have 5. A times a is a squared. And b times b is b squared, right? So we have 5ab. And then let's see, on the end, 2 times 6 is 12. A times A is A, B times B squared is B cubed. All right, so we have our GCF factored out. We're left with a trinomial, and now we can see, well, what can we do with this guy? This one's a little different because we have an A squared and a B squared, but I think it'll be very similar to the ones we've done before. So we want to, think about what we want to end up with. We want to factor this trinomial. The 2ab doesn't go away, still out there, but we want to factor the trinomial and the two binomials. Two expressions with two terms. So I know I need an a times an a to get the a squared, right? A times an a. And the tricky part then is going to be figure out what comes next. So we have this 6b squared on the end. We could think of that as our constant term even though it has a b squared. So 6b squared, we want to know if we can find two numbers that will multiply to give us 6b squared that will add up to negative 5ab, right? Or negative 5b. A is the variable. So 1 and, let's see, 1 and 6 somehow, right? 1 and 6. 1 times 6 is 6, and if we do 6 minus 1, we get 5, right? So we're going to use 1 and 6 somehow. Let's think about what we would do here. So we want to get a negative 5 there, right? Is this possible? We have two negatives possibly, or we have a negative and a positive. So let's think. Do we have a 6? 1 and 6 have 6. How about... if we have a negative 6, B, and a positive 1B, right? Oh, that doesn't really work though, does it? Because 6b times 1b is 6b squared. That works, but this is a positive 6b squared, and we would need them both to either be positive or both to be negative. So maybe that's not going to work, but what if we use 2 and 3? How about negative 2b and plus a negative, here, let me get rid of this. We'll make this better. 5 and 1 doesn't work. Sometimes we make mistakes, and that's good. And I like to model that sometimes. All right. So what if we use 2 and 3 and we make them both negative here? So a negative 2b and a negative 3b. And if we add those together, we would get our negative 5b, right? And there we go. And negative 2b times negative 3b gives us our 6b squared. Thought we were in trouble there, but all right, so this guy and this guy, we have our minus 2b, minus 3b. And I think we're in business. Now again, you could check, multiply the binomials, you would get the trinomial, and then multiply by 2ab, you would get back to where we started. And so we have successfully factored that one. Anytime they throw in an extra variable like that, it gets a little tricky, but you can handle it, I think. So I would pause the video right now and see if you can try this one on your own. But I'm going to go ahead and do it. So if you don't want the surprise to be ruined, pause it, try it on your own, and then you can check with the work that I do. So let's see, we have a trinomial. 10 will go into all three of those. K to the 4th will go into all three of those. So we factor out the GCF first. Then we see what we're left with. So we take a 10k to the 4th out of 10k to the 6th, we're left with a k squared. 10 times 7 is 70, k to the 4th times k is k to the 5th. 10 times 10 is 100, and we already have the k to the 4th. So that's our trinomial. Now let's see if we can factor that trinomial. We have our 10. We need two factors of 10 that will add up to 7. Ooh, how about 2 and 5? This one's pretty easy. 2 plus 5 is 7, right? So we have our 10k to the 4th that does not go away. We have our two binomials. So we have a k times k to give us our k squared, and we have our 2 times 5 to give us 10, so plus 2 plus 5. If we were to multiply those two binomials, we would get k squared plus 7k plus 10, and then if we distribute 10k to the fourth, we would end up with what we wanted. So this is our answer, and we are done with section 5.2. That should give you enough examples, hopefully, to get through section 5.2. So we'll see you in section 5.3 in the next video.